Welcome. In this tutorial we will be using the elimination method to solve a system of linear equations. This is example number 5. In this situation there is no integer by which you can multiply just one of the equations to be able to eliminate one of the variables. Here we will have to multiply both of the equations by different integers in order to achieve this. So let's get started. First, let's label the equations. That's our first equation, equation 1, and this is our equation 2. Next, I need to select which variable I'm going to eliminate, either the x or the y. For the purpose of this example, I will eliminate the x. In order to be able to eliminate the x terms, I need to take a look at the coefficient in front of the x. For equation 1, that coefficient is 3. And I have to think of the multiples of that coefficient, which are 3, 6, 9, 12, 15, 18, and so on. Then, for equation 2, I do the same and look at the coefficient in front of the x here, which is 5. The multiples of 5 are 5, 10, 15. Wait a minute. It seems that 3 and 5 have a common multiple of 15. This common multiple is actually the key to figuring out what the integer is that we need to multiply each of the equations by. Keeping the 15 in mind, what number times 3 will give you 15? Of course, that would be 5. 5 times 3 will give you 15. Now let's take a look at the second equation. Again, keeping 15 in mind, what times 5 will give you 15? And that would be 3. 3 times 5 gives you 15. So in this case, we're going to be multiplying the first equation, all terms of the first equation, by 5, and all terms of the second equation by 3. You may have noticed, well, all that we did was multiply the 3 by the 5 and 5 by the 3. That is often one way to be able to get the common multiple. Now let's see where this leads. If we multiply the first equation by 5, then we'd have to multiply each term by 5. So 3x times 5 is 15x, plus 5y times 5 is plus 25y, equals 3 times 5 is 15. Since this is a new equation, we'll label that as equation 3. Next, let's multiply the second equation by 3. 5x times 3 is 15x, plus 7y times 3 is plus 21y, equal to 9 times 3, which is 27. Again, this is a new equation, so let's label it equation 4. Now, I'm going to draw a line underneath this because we are actually, instead of adding, we are going to be subtracting. Subtract. And in this case, what we will be doing is taking equation 3 and subtracting equation 4. Now, why didn't we add this time? Well, let's take a look. If we add the 15x and the 15x, we would get 30x, and we wouldn't be eliminating the x terms. So in order to be able to eliminate, we need to subtract. So let's do that. 15x subtract 15x is 0, which means these terms are eliminated. Next, 25y subtract 21y gives us 4y, which is equal to 15 minus 27, which is negative 12. Notice this equation that we now have does not have an x variable, because the x variable has been eliminated. So let's solve for y. To solve for y, we need to isolate for y, and to do that, we just need to divide both sides by 4. The 4's divide out into 1, and 1 times y is just y, which equals negative 12 divided by 4, which is negative 3. This is the y coordinate for the solution, or the point of intersection. So we're basically halfway there. All we need to do is find the x value. In order to be able to find the x value, what we're going to do is we're going to be substituting this answer for y. We're going to substitute y equals negative 3 into one of our previous equations. It won't matter which equation you choose, they'll all lead to the same value of x. So I'm just going to copy out equation 1 just so I don't make any mistakes here, and I'm going to be substituting in y with negative 3. So everywhere I see y, I just replace it with negative 3 and then simplify the equation. Plus 5 times negative 3 is minus 15. In order to isolate x, I will first add 15 to both sides, which then gets rid of the 15s on the left side, leaving only just 3x equal to 3 plus 15, which is 18. Again, to isolate x, if I divide by 3, 3 divided by 3 becomes 1. It means 1x, and dividing the other side by 3, I get 18 divided by 3, which is 6. And this is the x coordinate of the solution, or the point of intersection. All we have left to do is to write our conclusion. Therefore, the solution, or the point of intersection of these two straight lines, is the ordered pair, starting with the x value, which is 6 in this case, comma, followed by the y value, which is negative 3, and that is the solution to this question. Now, if you're feeling adventurous, you can try this question again, except instead of eliminating the x terms, see if you can eliminate the y terms and come up with the same answer. If you do it correctly, you should end up with the correct solution.